Hey guys, Christopher here, and in this FreeCAD tutorial I'll be discussing how to use these different kinds of contours and a pocket tool in order to create the G-code for a sample part like this. I haven't really set a lot of dimensions in this sample part, but I have set the ones that I think are important for the G-code, like the depths and a couple of the radiuses, or radii. So with that, I'm going to go ahead and look at my tools. I always like to set them up before I start. I'm only going to be using my 1/4" end mill and my 1/2" end mill, not the center drill, so I have those set up the way I want, and I can go ahead and create my job. I'll stick with the default settings, and for this I'm not going to be worrying about the general output or work plan because I won't actually be exporting my file. But within these two tabs I need to switch to the create box without any of the extensions. I'm acting as though my stock is the same size as my part, and then move my origin up. So click on where I want it to be and set it. I already have my X and Y and Z axis where I'd like them, so I can go ahead and add my tool controllers for the two end mills. Remove the default, which I don't need, and add some values in where I need them. Okay, I have my job set up now with my two tools, and I'm going to show the base body, which is the shifted part after I move the origin, and hide my original body. I like to see the base body instead. And now we can start doing our operations. So in another tutorial I showed how to do the contour path for the base object. Now for a more complicated part like this, we've got a couple profiles that we need to do. There's the outside profile around this rectangle, and a profile around this rectangle, and then a pocket here. So if we wanted to do selecting a tool with the object profile, then apply. Okay, it's going to go around the edge of our part, and we can't really select where we want the profile to go. And that's why it's useful to have these other types of profiles. So I'm going to first use the face profile. I'm going to use my 1/2" end mill for this. And starting with the base geometry, this is where I would select what I want to profile, and I want to profile this rectangle right here. So I'll click on the face, add to the geometry, and I'm not going to change any of the depths or heights for now, and everything in the operation looks good. I have the correct tool, so I'll go ahead and apply and hit OK. Now we have it cutting around the outside of the rectangle like we want it. The depths aren't correct because we haven't set them yet, but it is going around the way we want it to. Now if you're going to do the same thing with the face profile on this part, it's not going to work as well because the face has this hole in it and it wouldn't know to go around the outside or the inside or both, since it's not a solid face. So for that, we're going to be using the profile based on the edges. So I'll click on that. Again, I'll be using the 1/2" end mill. And this time, in the base geometry, I'm going to just click on all four of these edges, making sure I'm holding control as I select them. And now, if I add all four, again, I'll just leave everything as the default for now and apply. We get the same thing that we got before. The depths are wrong, but we have our contour around the edge of the rectangle. And we don't have to worry about any of these inside edges because we just selected the outside edges. So that's two examples of when you would need to use these different types of contours. And then of course for the object contour we could just use that for the outside of the profile. So now I'm going to go ahead and set the heights for these profiles. First with the face one. For depths, it has these functions that you can change the values in the spreadsheet, but I'm just going to discard them and put in my own values. I like to start 10 thousandths above my part, and the depths on these are going to be -1/8 of an inch. Oops, keep editing that. And the step down, I will make that 20 thousandths. I'm going to keep the height the same. That's not too important for what I'm doing now, so I'll go ahead and apply. And now we've got something that looks more like a real toolpath. Now the profile of the edges, going to do really the same thing. Go to the depths, discard that, start 10 thousandths above my part, discard the final depth. Again, this is going to be 1/8 inch, and step down again is going to be 20 thousandths. Apply. Okay, and we've got these two toolpaths that look correct. For now, I'm just going to hide these so we can see clearly what we want to do next. Now I'm going to create this pocket with the pocket tool and with the 1/4 inch end mill so I can fit into the pocket a little easier. I will select my base geometry, which would just be the face, add it, and my depths. I will discard all of these, put in my own numbers. Start depth, like before, 10 thousandths. Final depth will just be 1/16 of an inch. And oftentimes I make my finished depth, my final depth the same, and then my step down will be another 20 thousandths. Heights I'll leave alone. Operation, everything looks good. We have the right tool, except I'm going to change the pattern from zigzag to offset. Actually, if I apply before that, you can see that it's going to come around and cut that, but there's going to be a part over here that's not cutting. So I change it to offset, reapply, and that looks a lot better. Okay, and we have our pocket geometry cut out. I'm going to hide that, and lastly just cut out the contour using the base object contour, which I showed in another video. So 1/4 inch end mill, depth, discard. Actually, you can add these values in the spreadsheet, but sometimes I find it easier just to put in the values right here. Final depth, I want to go the full 3/8 and a step down of 20 thousandths. This all looks okay, so apply, and showing all of our toolpaths. Looks like we've got a pretty complete part, but still sometimes it's hard to tell to try to visualize what all these toolpaths are doing. So you can, I'm going to hide these, and then simulate using this tool up here. This will show us if there's anything we did wrong. It shows the full stock that we have to start with, and it'll go ahead and cut it away. Actually, I can turn the accuracy down. It'll make it go faster. And then go ahead and run and watch and see what it does. So with the accuracy so low, got a lot of pixels, but we can still see what's happening. So the pocket looks pretty good, but some things that don't look good would be this. In order to get rid of that, we would have to add another facing operation. And also, I intentionally did not put an internal corner radius right here to show that that's something you can catch If I hit OK, come down, show that here is the material that is created. If you hide it and show it, then you can see more easily what's missing or what's extra, and you can see that it can't cut that internal corner radius so sharply. It's the minimum radius is going to be 1/8 of an inch because you used a 1/4 inch tool. So you can catch things like that using the simulate. And also it's nice to see what stock you have left over, so it shows us that we have this little bit of scrap. If you're running multiple parts, you might be able to try to minimize the scrap that you're creating, or maybe if you have a small part you can run right here. It'll save you time and material. So this simulate's pretty useful for those kinds of things, but I'll just delete it. I can see that of course there would be some changes that I need to make to this if I were actually going to try to run it on a CNC machine. But these profiles and pockets are probably the most common operation you'll use on a CNC. Very useful to know how they work, and hopefully that's an explanation that you can use to create your own parts on a CNC using FreeCAD. So if you like the video, make sure to subscribe and give it a thumbs up. Thanks for watching.